about this wireless sensor network. Good morning. So today we'll start the wireless sensor network functionalities. Okay. So this wireless sensor network management, it is composed by configuration, sensing, processing, communication, and maintenance functionalities. Okay. So it will be having configuration, sensing, processing, communication, and maintenance functionalities. So under configuration, this configuration functionality, it involves procedures related to planning, placement, and self-organization of wireless sensor network. Okay, this configuration involves the procedure related to planning, placement, and self-organization of a wireless sensor network. So this configuration functionalities are related to the definition of wireless sensor network application requirements. Okay, application requirements and monitoring area, that is the shape and dimension of the network size. Okay, then the characteristics of the environment, choice of nodes, and the wireless sensor network type, then the service provided. Okay, these everything will come under configuration. Okay, so the functionality related to planning, placement, and self organization of a wireless sensor network comes under this configuration. So the work for this configuration, that is the what are the works carried under configuration. One is the wireless sensor network application requirements, then the monitoring area, determination of the monitoring area, or we can say that the size and shape of the network area, then the characteristics of the environment, then choice of nodes, choice of nodes, then the size, type, wireless sensor network type, then the service provided. So in the deployment phase, the sensor nodes can be placed by dropping them from a plane, rocket, or missile, and placed one by one by a human or robot, like anything, like anyhow we can place the sensors. We can deploy the sensor. So any placement approach for sensor nodes must be considering as an expensive and difficult redeploying nodes. We cannot redeploy it. Okay, so wireless sensor network applications, these wireless sensor networks are application specific. That means if we are specifying the sensor for one particular application, that application alone can be processed by that particular sensor node. Okay, so this is about the configuration. So these nodes will be grouped. Okay, that is, if you consider the network management level and management functional areas based on the configuration functionality, this wireless sensor network can be classified into various ways. Okay, so a wireless sensor network is said to be homogeneous when all the nodes have the same hardware. Already I told you, right? If all the nodes have the same hardware, then we can call that particular wireless sensor network as homogeneous network. Or if it is different, then we'll be calling it as heterogeneous network. So a wireless sensor network is a hierarchical when nodes are grouped into the purpose of communication. Okay, or else it is flat. If it is grouped into purpose for the purpose of communication, it will be a hierarchical, or else the architecture will be a flat one. So when the nodes are stationary, we'll be calling that wireless sensor network as a static. Otherwise, we'll be calling it as a dynamic network. So the topology may be dynamic even when the nodes are stationary. Topology may be dynamic even when the nodes are stationary, because the new nodes can be added to the network, or sometimes the existing network may become unavailable. So your topology should be dynamic whether the nodes are static or dynamic. Okay, in both the conditions, the topology should be a dynamic one. Why the topology is dynamic one? Sometimes new nodes will be joining in the network, or sometimes the nodes present in the network itself will become unavailable. So for that case we need to use the dynamic topology only. So wireless sensor network is symmetric concerning the signal transmission. That is, when each receiver has the same transmission range, and so each transmitter has the same transmission range, then we'll be calling that wireless sensor network as symmetric, or else it is asymmetric. Then this wireless sensor network is said to be regular concerning about the node placement. When nodes are placed in a grid, okay, so if the nodes are placed in a grid topology, in the grid fashion, then we'll be calling it as it is as a regular wireless sensor network. Or else if the nodes are placed random, then we'll be calling it as irregular. Okay, this is based on the node topology, node placement. So these are the types of wireless sensor network what I am telling. Okay, so based on the node placement, it is regular or irregular. And based on the transmission range, it is symmetric or asymmetric. And based on the nodes condition, it is static or dynamic, right? So there are so many types. So if it is randomly distributed, the nodes are randomly distributed, then we'll be saying that that wireless sensor network is irregular one. Okay. So considering the network element management level and the management functional areas based on the configuration functionality, the sensor node in a wireless sensor networks are spread over a region and communicate among themselves using point-to-point wireless communication. So thus it forms the ad hoc network. So the nodes are autonomous when they are able to execute location discovery and self-configuration task. So this without any human intervention. Okay, without any human intervention, the nodes are able to execute, or nodes are able to find out the location, and also if it is self-configured, then we'll be calling that particular nodes as autonomous. And wireless sensor node also comprises one or more sensor elements and battery, memory, and processor. Everything we have studied. The size of the node is an important consideration, right? So the nodes need to have small, the size of the node should be small one. So here the wireless sensor network protocol, if you can, it can be classified into architecture, data handling, MAC, medium access control, location discovery, and some maliciousness, right? So this architecture, it can be two types: layered architecture or clustered architecture. So we'll see the architecture first, then we'll be going for this data handling. So the sensor network architecture, two basic sensor network architectures are layered architecture and clustered architecture. So this is the structure of layered architecture. You will be having a base station, and if it can reach the information in a single hop, then we'll be calling it as one hop layer. Okay, here you'll be having number of layers, right? So this dotted line indicates the coverage area. Okay, so this dotted line indicates the coverage area, and here this dark black, these dots are nodes. Okay, sensor nodes. So here this is a base station, and if you consider here, each node can communicate with other node with a single hop, right? Suppose if this node wants to communicate with this node, just a single hop. Hop is nothing but how many node it is crossing from the transmitter to the receiver. So here assume that this is the sender and this is the receiver. Okay, it can directly communicate. That is, these nodes can communicate directly. So that is called one hop layer. Okay, so this distance, this is 2-hop layer, and this is the 3-hop layer. So if this node wants to communicate with the other node in the other layer, it has to take 2 hops from the base station. Here it is 1 hop, and this is the second hop, and this is the third hop. Likewise, we'll be considering the hop. Okay. So the layered architecture has a single powerful base station. We'll be having a single powerful base station, and the layers of sensor nodes around it corresponds to the nodes that have the same hop count to the base station. So here it is same hop count to the base station. So here this unified network protocol framework, it integrates 3 operations in its protocol structure. Okay, this unified network protocol framework, we'll be calling it as UNPF. It integrates 3 operations in its protocol structure. First one is network initialization and maintenance, then medium access control protocol, then routing protocol. So this UNPF, first we'll see how the network is initialized and how it is maintained. So this base station, it broadcasts its ID using a known CDMA code on the common control channel. That is this base station. Okay, so this base station, it has to find out this all the nodes, whether it belongs to 1 hop distance or 2 hop distance or 3 hop distance, right? It has to identify. So for that reason, this base station, it will send a signal like a beacon. Okay, so these nodes will receive the beacon signal, and it will be responding to the base station. Okay, so now this base station will identify that these are the neighbors. Okay, and these are the neighbors, and these neighbors can be reached with a single hop distance. Okay, again these nodes will send a beacon signal. Okay, so this will reach by this signal. So this information will also be received by this base station. So now this base station will able to identify that these are the nodes which can be reachable with 2 hop distance. The same way this process repeats, and this base station will be able to know the nodes which are reachable with the single hop, and the nodes which are reachable with 2 hop, and the nodes that are reachable with 3 hops. Okay, likewise this base station will have the information. So the base station broadcasts a beacon signal. Okay, so all the nodes which hear this broadcast will record this base station's ID. Okay, so once a node is receiving a signal from base station, immediately the node will record this base station ID, and then they send a beacon signal with their own ID. Each node will have their own IDs, right? So these nodes will send a beacon signal with their own IDs. Okay, and the power level will be naturally low power level. Okay, because the beacon signal will be very often each node will be transmitting the beacon signal just to know whether the nodes are active, or if any other new nodes are joined in the network, or any nodes have drained its energy, to monitor that. Sometimes some node may become unreachable. Okay, just to monitor that, it will be sending this beacon signal often, okay, with low power. Okay, so those nodes which a base station can hear from layer 1. So then this base station broadcasts a control packet with all layer 1 nodes IDs. Okay, so all nodes send a beacon signal again. Likewise, it can hear from the second layer and in the third layer. So the entire coverage area will be covered by the base station. Likewise, the network initialization is done, and the maintenance is done by this beacon signal. Often, that is very often, it will be sending the beacon signal so that so that this base station will know who are the nodes that are active and who are the nodes they have joined newly. What are the nodes they have joined newly? Okay, that is about the network initialization and maintenance. So next is MAC protocol. Okay, so during the data transmission phase, once that is a network is initialized and maintained, naturally the next is data transmission, right? So during the data transmission phase, this channel assignment is used, that is distributed time division multiple access receiver oriented channel assignment, because each node has to find a path. Okay, so suppose if this node wants to communicate with this node, it has to find the shortest path based on any of the algorithm. Okay, so many researchers have done so many researchers regarding channel assignment. So based on the channel assignment, it has to find out the lowest distance. The distance should be minimum, and what can we say? The interference should be minimum, and the hop count should be minimum. That is, it has to select the lowest path. Shortest, not the lowest path, shortest path. It has to find out the shortest path. So here in the MAC protocol, the most used algorithm is this one, distributed time division multiple access receiver oriented channel assignment, that is DTROC. The algorithm name is DTROC, distributed time division multiple access receiver oriented channel. Okay, channel assignment MAC protocol is used, okay, during the data transmission phase. So here in this algorithm, there are two steps. First one is channel allocation and the second one is channel scheduling. So channel allocation is each node is assigned a reception channel by the base station, and the channel reuse is such that the collision can be avoided. Okay, there should not be any interference, or we cannot, the two nodes, that is two nodes cannot use the same channel for transmitting different uh, information. Okay, the two nodes, if they want to transmit the same channel, that is once it finds this path, assume that this node wants to communicate. I'll draw it. பெண்ணே வர மாட்டேங்குது. So now pen is not working. So assume that here, okay, it's working. This node wants to communicate with this node, and it is finding this point as the shortest path. Okay, so now these nodes cannot assume, these nodes, suppose this node wants to communicate with this node, it cannot use this path because this node is already involving in this communication. Okay, so it has to select another path in such a way that the communication is not interrupted. Okay, so that is nothing. If the communication, one node information is mixed with other nodes information, then collision will be occur. So to avoid collision, we need to select the channel in such a way that that particular nodes are in this procedure only. We need to select the path. Okay, that algorithm itself will select the path. Next is channel scheduling. So the node schedules transmission slots for all its neighbors and broadcast the schedule. Okay, so schedule in the sense for this time this node is going to communicate. So that transmission slot, since it is time division multiple access, so this particular time this node will be involved in transmission, everything will be scheduled. Okay, so the node schedules transmission slot for all its neighbors and broadcast the schedule. So this enables collision free transmissions and save energy, and it saves the energy, as the node can turn off when they are not involved on the uh, transmission or reception. So here for the MAC protocol, we'll be using this distributed time division multiple access receiver oriented channel assignment. So here this algorithm has two steps. One is channel allocation and the other one is channel scheduling. Channel allocation is each node is assigned a reception channel by the base station, and if there is any channel reuse, we can reuse the channel in such a way that the collision can be avoided. Okay, that is channel allocation. That is channel allocation is nothing but finding the shortest path between the sender and the receiver. So next is channel scheduling. Channel scheduling is here, since we are using time division multiple access, each nodes can transmit with a specific time. Okay, the time slots will be that is the transmission slot. So the node schedules the transmission slot for all its neighbors and broadcasts that schedule, so that other nodes cannot interrupt this node at this particular time. So this enables collision free transmissions and saves energy. So when the nodes are nothing to transmit, then it can sleep. Okay, the nodes can turn off or it can sleep when they are not involved in any transmission or reception, so that it can save its energy. So the downlink from the base station is direct broadcast on the control channel. So uplink from the center node to base station is by multi-hop data forwarding. Okay, downlink is by direct broadcast and uplink is by multi-hop data forwarding. So the node to which a packet is to be forwarded is selected by considering the remaining energy of the nodes. Okay, so this achieves the higher network lifetime. So if we are taking a path, we need to check the remaining energy, the balance energy of that particular all the nodes. Okay, energy, balance energy of the all nodes. So the node to which the packet is to be forwarded is selected by considering the remaining energy of the nodes. So this achieves the higher network lifetime. Okay, so this is about the routing protocol. Okay, so we have studied this network initialization and maintenance. First, by giving the beacon signal, the network is initialized, and by the beacon signal itself, it will check whether the nodes are, the new nodes are added to the network, or any network which belong, any nodes that belongs to that particular network become unavailable. Okay, likewise, it will be getting the information by periodically transmitting the beacon signal. Then the MAC protocol is for channel allocation and channel scheduling, and routing protocol is to find out the path. Okay, to in between the nodes, if you are finding a path, so from the sender to receiver there will be so many intermediate nodes. So we need to select the, we need to find out the energy levels of all the nodes, and the nodes which is having the highest energy has to be considered for following the path. Okay, for identifying the path. Okay, that is the purpose of the routing protocol. So this is about the layered architecture. Layered architecture, you'll be having a base station, then 1 hop layer, 2 hop layer, and the 3 hop layer. Okay, so this is the dotted line is the coverage area. This is the sensor nodes. Next, we'll go for clustered architecture. Do you have any doubt in the layered architecture? Layered architecture, do you have any doubt? Then we'll go for clustered.
No, ma'am.
No, okay, okay, Ajay, thank you. So clustered architecture, I'll show you the diagram first. So this is the clustered architecture. There is a base station. Okay. So here cluster of networks. Okay. Cluster of networks. So this is one cluster, this is another cluster, this is another cluster. That is, nodes are grouped as a cluster. Okay. Nodes are grouped as cluster. So if you consider this area, all these nodes in that area has to elect one cluster head. So here, this is the cluster head. See here, this symbol indicates that this is the cluster head. So for this portion, this is the cluster head. So only the cluster head will be communicating with the base station. So all the other nodes will send the information to the cluster head. So this cluster head has to monitor the information, and this information will be, the cluster head only give the information to the base station. Okay, this is the clustered architecture. So the clustered architecture, it organizes the sensor nodes into clusters. Okay, so organizes the sensor nodes into clusters, and each clusters are governed by cluster head. So this cluster of nodes will be governed by this cluster head, and this cluster of nodes can be governed by this cluster node. Okay, in the same way here again. So only the cluster head will be communicating with the base station. So the nodes in each cluster heads are involved in message exchanges with their cluster head. Okay, and these cluster heads send the message to the base station. If you see here, see all the nodes are sending information to only cluster head. Okay, see here, this is the representation for cluster head. The dotted node, dark dotted is dot is sensor node, and the arrow is flow of data. So from the node, the data is flowing to the data flow is towards the cluster head, right? So from the cluster head, it is coming to the base station. Now directly from the node, none of the information is coming to the base station. Okay, so that is the clustered architecture. Nodes have to give the information to the cluster head, and the cluster head have to give the information to the base station. So that is written here. That is, the clustered architecture organizes the sensor nodes into the clusters. So each governed by the cluster head. So the nodes in each clusters are involved in message exchanges with their cluster heads, and these cluster heads sends message to the base station. Okay. So now clustered architecture is useful for sensor network because of its inherent suitability for data fusion. So the data gathered by all members of the cluster can be fused at the cluster head, and only the resulting information needs to be communicated to the base station. So all the data, it is not necessary that the data from all the nodes have to reach the base station. Okay, so all the data will be coming to the cluster head. So the cluster head will be fusing the data. Okay, so the cluster head will give the resultant information to the base station. So the cluster formation and the election of cluster head must be an autonomous and distributed process. How the cluster head can be elected. So if you consider, the cluster head is also a node only. Okay, so cluster head is also a node. So one chance is, the node which is near to the base station can be elected as a cluster, or the node which is having the highest energy among these clusters, among these cluster will be elected as cluster head. Okay, so these nodes will be having, or else the cluster head can be selected randomly, or on time basis the cluster head can be there. For sometimes one node will be the cluster, and for next sometime another node can be the cluster. Likewise they can take turn. Okay, it is there, the node's own choice, okay, based on the algorithm. Okay, so one choice is the node which is closer to the base station, or we can say the node which is having highest energy. Okay, suppose within the cluster, if two nodes are having the highest energy, same energy, then randomly one node can be selected, can be a cluster head. Okay, so they only will be electing the cluster head, or else sometimes some node, that is on time basis, the cluster head can be allotted. Okay, so here the algorithm is Leach algorithm for electing cluster head. That is, Leach is low energy adaptive clustering hierarchy. Leach is low energy adaptive clustering hierarchy. So the Leach is a clustering based protocol. It minimizes the energy dissipation in sensor network. Suppose, see here, this node, this cluster head will be always involved in transmission, right? So, but these nodes, if they have some data to transmit, they will be transmitting it, or else it will be in the sleep mode. So, the energy of the cluster head will be drained more fastly when compared to other nodes in that particular cluster. So, if the energy level becomes low, naturally another node will be elected as a cluster head, and this will be acting as a node, as a ordinary node. So Leach is a clustering based protocol, and it minimizes the energy dissipation in sensor networks. So the operation of the Leach is split into two phases. One is setup phase and the other one is steady phase. Okay, so setup phase, the sensor node chooses the random number between 0 and 1. Okay, as per this algorithm. So each sensor node chooses a random number between 0 and 1, and if this selected number is less than the threshold, if this is lower than the threshold for a node n, then the threshold of n, T of n, that is, it will be selecting a random number, right? So then it will be checking all its energy. Okay, so if the energy level, the highest energy, if one node has the highest energy, that node will be acting as a cluster head. So after selecting the cluster head will advertise its position to all the nodes, indicating that it is the cluster head. So all the nodes will choose the nearest cluster head by the signal strength. So if you consider this diagram, so sometimes this node can receive the cluster head information from this cluster also, but this cluster head's signal will be high when compared to these two clusters. So these nodes will be monitoring the cluster head based on the signal strength. Okay, so all the cluster head will send the information to the nodes, but based on the signal strength, each node will select, each node will what to say, mm, maintain its cluster head. Okay, all the nodes choose the nearest cluster head by the signal strength. So the cluster head then assigns this TDMA schedule for their cluster members. That is, this node can transmit at this time, this node can transmit at this time, like this algorithm. Based on this algorithm, it can give the TDMA schedule for their cluster member. Okay, this as done in the setup phase. And in the steady phase, the data transmission takes place based on the TDMA schedule. Okay, so setup phase is network setup and steady phase is data transmission. Okay, so steady phase, the data transmission takes place based on the TDMA schedule, and the cluster head perform the data aggregation, that is collecting the data, then maintaining the records, and just to send the information to that is base station. So data compression or whatever, data processing, whatever has to done, this data cluster head will do it. Okay, so after certain period of time in the steady phase, cluster heads are selected again through the setup phase, because since the cluster head is active for so long time, its energy may reduced when compared with the nodes in the other nodes in the cluster. So it has to re-elect the cluster. So the cluster head. So the cluster head re-election will takes place. Then it has to go to the setup phase. Okay. So this is about the architecture. So data dissemination we will see in the next class. So answer your attendance. Ajay,
Present, ma'am.
Abhishek,
Present,
Abhishek,
ma'am. Present.
Jeevan,
Present, ma'am.
Andrew,
Present, ma'am.
Shervin, Shervin
Present,
69.
ma'am.
Okay, ma. Amarnath,
Present, ma'am.
Govardhan,
Yes, ma'am.
Nikita,
Present, ma'am.
Bijo,
Present, ma'am.
Hariharan,
Present, ma'am.
Jovin,
Present, ma'am.
Jeswin,
Present, ma'am.
Julian,
Yes, ma'am.
Patrick,
Yes, ma'am.
Kevin, Kevin, Kevin absent. 1104. Sanjay,
Present, ma'am.
Prince,
Present, ma'am.
Harika,
Present, ma'am.
Pallavi, Pallavi, Pallavi is here, no?
Yes, her device got stuck.
Okay, ma. Okay. So all of you got the link today. Kevin Collins is, I think he has joined now, right?
Yes, ma'am. Sorry, just talk.
1104. Any other who didn't receive the link? Other than Kevin Collins, all might have received, right? If you have
Ma'am,
not,
I too got the link, ma'am.
you got the link.
Yes, ma'am. Yes, ma'am.
Okay, okay, okay. Kevin, you have come. Actually, I marked you. Okay. Okay, Kevin. You have any doubts?
No, ma'am.
Okay, ma. If you don't have any doubts, you can leave. Thank you. Thank you for attending.
Ma'am.
Yes, ma.
Ma'am, like while uploading in the GCR, I have seen only recording sessions are there, ma'am. There's no PPTs. Like just to even for
Yeah,
revision, I
just now
upload.
I have uploaded only the recordings.
Yeah, ma'am. Can you please upload the PPT too, ma'am?
I'll upload.
Yes, ma'am. Thank you.